You just finished dinner, your stomach is full, but somehow you're already thinking about dessert. That little voice isn't weakness. It isn't a lack of willpower. The real answer is far stranger. It's a message from deep inside your brain, sent by ancestors who never tasted a candy bar in their lives. To understand why, you have to go back. Not a few years, not a few generations, millions of years, to a time when sugar was one of the rarest things on Earth. Picture a small group of early hominins moving through a forest in East Africa. Food is unpredictable. Some days bring nothing but tough leaves and bitter roots. Then, every so often, someone spots it. A cluster of ripe fruit, hanging heavy and bright against the green. That fruit is sugar. And in that moment, sugar means something very specific. It means survival. Anthropologist Nathaniel Dominy has spent years studying how early humans interacted with fruit-bearing trees. And his research points to something remarkable. The ability to detect ripeness, especially through color and smell, may have shaped the evolution of human vision itself. Many researchers argue that our ancestors' shift toward trichromatic color vision, the ability to see a full range of reds, greens, and yellows, was driven partly by the need to spot ripe fruit against green foliage. Think about that for a second. Part of the reason you can see the color red as vividly as you do may be because your ancestors needed to find sugar. But spotting fruit was only half the equation. The other half was what happened once they ate it. Ripe fruit doesn't just taste good. It delivers a fast, concentrated hit of energy. Glucose, the simple sugar found in fruit, is the preferred fuel for your brain. Your brain, despite being only about 2% of your body weight, burns through roughly 20% of your daily energy. It is, in evolutionary terms, an extremely expensive organ to run. So when a brain like that found a food source that delivered immediate, easily absorbed fuel, something had to happen. The brain had to make sure you'd come back for more. That's where dopamine enters the story. Dopamine is often called the feel-good chemical, but that's a little misleading. It's less about pleasure itself and more about motivation. It's the chemical that says, remember this, do it again. When early humans ate sugar-rich fruit, their brains released dopamine, not as a reward for being good, as a signal. A signal that said, this thing you just did, finding and eating this, that was important. File it away, seek it out again. Multiply that signal across thousands of generations, and you get something powerful. A brain hardwired to treat sugar as a 5-alarm priority. Not a luxury, not a treat. A priority on par with finding water or avoiding a predator. Here's where it gets stranger. For almost all of human history, sugar was rare and seasonal. Fruit ripened for a few weeks a year, then disappeared. Honey existed, but it was guarded by bees and hard to reach. There was no scenario, none, in which a human could eat unlimited sugar every single day. Because of that, evolution never needed to build in an off switch. Why would it? The environment did that job automatically. Scarcity was the off switch. Researcher Daniel Lieberman, who has spent decades studying the evolution of the human body, points out that many of the systems we now consider broken, like our craving for sugar, fat, and salt, weren't designed with restraint in mind because restraint was never necessary. The world itself rationed these things. Now think about your kitchen, your pantry, your fridge, the vending machine down the hall, the drive-thru that's open at midnight. None of that existed for 99.9% of human history. And yet, your brain, the same brain shaped by millions of years of scarcity, is still running the same software. When you see a donut, a part of your brain doesn't process it as donut. It processes it the way your ancestors' brain processed a perfectly ripe, hard-to-find piece of fruit. Rare, valuable, take it now, because who knows when you'll see it again. Except now, it's never rare, it's everywhere, and your brain hasn't caught up. This mismatch has a name in science. Researchers sometimes call it an evolutionary mismatch, a gap between the environment your body was built for and the environment you actually live in. Your eyes were built for spotting fruit and green leaves. Your dopamine system was built for an environment of scarcity, and your taste buds were built to detect sugar as a rare and precious signal of energy. But the world changed far faster than your biology could. Here's the counterintuitive twist. Your craving for sugar after a full meal isn't a malfunction. It's actually proof that your reward system is working exactly as designed. The problem isn't the wiring. The problem is the environment that wiring was never built for. There's another layer to this, and it has to do with taste itself. Humans are born already preferring sweet tastes. Studies on newborn infants, even just hours old, show a clear preference for sweet liquids over plain water, often shown through relaxed facial expressions and increased sucking. This isn't learned. It's there from the very beginning. Why would a newborn, who has never eaten a piece of candy, already crave sweetness. Because breast milk itself is sweet. Lactose, the sugar in milk, gives it a faint sweetness that human infants are primed to seek out. A preference for sweet flavors may have helped infants identify safe, energy-rich food sources. Breast milk being the clearest example, while helping them avoid bitter tastes, which in nature often signal toxins. So before you could walk, before you could talk, your brain was already wired to associate sweetness with safety and energy. Now fast forward to adulthood. You've just eaten a full meal. Protein, vegetables, maybe some rice or bread. Your stomach sends signals to your brain, you're full. You don't need more calories. And yet, the craving for something sweet persists. Part of this comes down to something researchers call sensory-specific satiety. You can feel completely full on savory food, yet still have room or desire for something sweet because your brain processes different tastes somewhat separately. Eating a lot of one flavor profile doesn't fully shut down the reward signal for a different one. In other words, being full of dinner doesn't mean you're full of sugar. Your brain is still keeping score on a separate ledger. There's also the matter of what sugar does to your brain's chemistry in real time. When you eat something sweet, especially something high in both sugar and fat, like cake or ice cream, your brain releases not just dopamine, but also opioid-like compounds, your body's natural feel-good chemicals. Some researchers have compared the brain's response to highly palatable foods to its response to certain addictive substances. Not because sugar is identical to a drug, but because it activates overlapping reward pathways. This doesn't mean sugar is evil, or that wanting dessert makes you weak. It means your brain is responding exactly the way millions of years of evolution shaped it to respond to a stimulus that, for almost all of human history, was a rare and valuable gift. So what do you do with all of this? Understanding where the craving comes from doesn't make it disappear, but it does change what it means. The next time you finish a meal and suddenly find yourself thinking about something sweet, that's not a personal failing. That's not your body betraying you. That's a message, ancient and deeply rooted, from a long line of ancestors for whom finding something sweet could mean the difference between thriving and starving. Your brain isn't broken, it's just old. It's running code written for a world of scarcity, and you're living in a world of abundance. You finish dinner, your stomach is full, but somehow you're already thinking about dessert, and now you know exactly why.